Dear students, in the previous class has started module number 1, that is vector calculus. In the previous class I have given the complete basics and the three main concepts in the vector calculus, that is gradient, divergent, curl and the directional derivatives. So before going to the actual example, so today so I will go for the few illustrative examples how the grade problems will work out, then divergence of a vector how it work out, and curl. So these three concepts I want to show now. So this is not important for exam, but you should know how this gradient of a scalar supposed to be calculated, then divergence of the vector is supposed to be calculated, and curl of the vector. So with the help of that you will be able to write any of the answer in the future of the classes what I am going to be conducting. So we'll see the example now. So illustration, so I have taken one example here. So given phi is nothing but scalar, because you can find here no ijk, only a quantity, that is a volume here. So or means a magnitude. So find grade phi. So I have taken, so given phi is equal to x square y plus y square of z plus z square of x here. So this is the value of phi. So we need to find grade phi now. So now grade phi is given by grade phi, which is symbolically written as what here, del phi. So this can be written as according to symbolically. So del value is nothing but what here, dou phi by, I am writing directly, dou phi by dou x of I plus dou phi by dou y of j plus dou phi by dou z of k. So this is nothing but a grade phi formula. So here we'll replace this phi value and we'll see. So which is equal to dou by dou x of, the value is what here, x square y plus y square z plus z square x of I plus second term, replace this complete phi. So dou by dou y of, that is x square y plus y square z plus z square x of j plus, I'll write next term down here, plus dou phi by dou z of k, that is dou by dou z of phi value is what here, x square y plus y square z plus z square x of k. Now so each partial derivative we need to apply correctly now. So first we have almost three partial derivatives, that is with respect to x, with respect to y and with respect to z. So first term, coefficient of I. So we need to this bracket, we need to go for partial derivative with respect to x. So while making a partial derivative with respect to x, treat y and z as a constant now, because this phi is a variable of what here, x, y, z, three variables it includes. So therefore with respect to x means, so in the first term, so partial derivative of x square with respect to x is what here, 2x, and this y constant as it is, plus, so y square and z square purely constant with respect to x is what here, 0, plus z square is a constant, keep as it is, partial derivative of x with respect to x is 1. So first partial derivative is completed into I, plus next one, dou by dou y of this result, that is with respect to y we need to calculate. So at that time with respect to y means we have to treat x and z as a constant. So here, so x square is a constant, so partial derivative of y with respect to y is 1, plus with respect to y means partial derivative of y square is 2y and z is a constant, plus, so z square and x is purely constant with respect to y, 0 of j, plus next, so third term, that is plus what we have down. So with respect to z means x square and y is purely constant, 0, plus y square is a constant, partial derivative of z with respect to z is 1, plus z square into x A partial derivative of that with respect to z is what here? 2z into x of k. So now simplify, we'll get, so on simplification we'll get what here? 2xy plus z square of I plus x square 2yz plus times 2yz of k, plus from here we'll get y square plus 2xz of k. So in this way, so we got this result. So this is nothing but therefore I can say that I'll rewrite it. So grade phi is nothing but 2xy plus z square of I plus x square plus 2yz of k plus y square plus 2xz of k. So this is the way to find what here? The given scalar quantity with grade. So similarly, I want to go for one more illustrative example. So that second one is, given vector A. So I have taken here vector value because vector will work out for divergence and curl here right now. So vector A is given by x square y of z of I plus y square zx of j plus z square xy of k. Then find the divergence of A and divergence of what here? And curl of A. So we'll see one by one both here. So vector A they have given what here? X square yz of I plus y square zx of j plus z square xy of k. So this is a vector quantity. So we need to check for divergence of vector A now. So divergence of vector A, that is symbolically written as what here? Del dot vector A. So del is nothing but what, so this is going to write it as, so del value is nothing but what here? It is dou by dou x of I plus dou by dou y of j plus dou by dou z of k dot, the value of A is what here? X square y z of I plus y square zx of j plus z square xy of k. So with the help of this, so we need to go for dot product. So I told dot product, always I term you multiply with I, j term you will multiply with j term only, k term you multiply with k. So on multiplying, so I dot I will become 1, j dot j will become 1, k dot k will become 1. So therefore it will become dou by dou x of first bracket, that is first term, x square yz plus into plus is plus dou by dou y of second term y square zx, because j dot j is 1, leave it, plus k dot k is 1, so leave it. So third term, so dou by dou z of the third term z square xy. So on simplification, so first term we have to differentiate partially with respect to x. At that time what happens? Y and z are constant. So partial derivative of x square with respect to x is what here? 2x plus. So next is y square, we need to differentiate partially with respect to y. Zx is constant. So therefore partial derivative of y square with respect to y is what here? 2y plus here z square xy we need to derivate partially with respect to z. So that's why it will be 2z xy is constant. So on simplification, divergence of vector A is equal to, you take 2 common among this, okay, or else I think all it is 2xyz, it is 2xyz and it is 2xyz. So all are like terms, so I can say that 2 plus 2 plus 2 is 6 times xyz. So we got the answer, divergence of A as what here? 6 times xyz. So similarly we need to go for next concept what they have asked here, it is curl of A. So I will check how the curl will be going to find here. So curl of vector A, symbolically it is del cross vector A, that is determinant. So I, J, K. So second row is also fixed, that is dou by dou x, dou by dou y, dou by dou z. So this is fixed only when if they have given the value of a given vector is supposed to be in terms of x, y, z. If it is in case of p, q, r, so it will become dou x, dou by dou p, dou by dou q, dou by dou r. So it depends on what variable they have given for the given vector, that will be fixed here. So first row is fixed, that is ijk. Second row here it is fixed, dou by dou x, dou by dou y, dou by dou z. And next is what here we need to write next coefficient of what here I is what here x square y z. So it's supposed to be here, write it. So x square y z. Then coefficient of j is what here y square zx. And coefficient of k is what here z square xy. So we need to simplify this determinant now. So simplification of this determinant is, that is I times bracket. So dou by dou y of this term. So I will go directly. So partial derivative of this term with respect to y, it is what here z square x, because y is 1. I am writing directly. Formula minus partial derivative of this term with respect to z. So here z is 1 time. So at that time y square and x is constant. Partial derivative of z with respect to z is 1. So y square and x is what here constant. Close it. Minus j times. Next, partial derivative means first row and middle column we have to hide. So partial derivative of this function with respect to x partially means what here it will be z square y minus, so partial derivative of x square yz with respect to z is what here x square y plus k times. Next, so first row and third column, so partial derivative of y square zx with respect to x is what here y square z minus partial derivative of x square yz with respect to y is what here x square z. So now on the simplification you will see that is curl of vector A is equal to, among the first bracket I will take x common, what left inside z square minus y square of I minus, or I will take minus sign common among this, I will make it plus. So among this y is a common, so if I take minus, so what happens here x square minus z square will come of kj plus, and among this you take z common, it will be y square minus x square of k. So this is the way to simplify for what here gradient, divergence and curl. So remember, so how it works for the gradient, and how to find the divergence of any vector quantity and curl of any vector quantity. So with the help of this illustrative examples, so we'll go for the actual examples, which is very important for our examinations.